Okay, so we are back for one more thing. And yes, I'm going to ask you to put these things in your notes, even though they're typed, even though I'm not writing them down right now. And the reason for you putting them in your notes is because if you write them down with your hands, you will remember them better than if you just stare at them on a computer screen. So you can title this Guidelines for Drawing Lewis Dot Structures, or Rules for Doing Lewis Dot Structures, or Stuff Mrs. Sullivan Said That Will Help Us Draw Lewis Dot Structures. I don't care. Give it some sort of title so you know what it is. The first thing you do is draw what's called the skeletal structure. Okay, the skeletal structure is a two-dimensional picture of the elements in the atom. So let me see. So if I had water, for instance, H2O, I would put O in the middle and H on the outside. We'll figure out why O is in the middle in a minute, but this is a skeletal structure. Just how you think the arrangement of the atoms should be on a piece of paper. So first thing, draw the skeletal structure, and you put the more electronegative elements on the outside, and hydrogen and fluorine are always terminal, meaning they are always at the ends. Hydrogen and fluorine will never be in the center. So, skeletal structure, most electronegative elements on the outside. Are we okay? I hope so. The next thing you want to do is total up the number of valence electrons. You get the valence electrons from the group the element is in. Group 1 is going to have 1 valence electron. I should probably write this down somewhere, huh? So you're going to total the valence electrons. Group 1 is going to have 1 valence electron. Group 2 is going to have 2 valence electrons. We skip across to group 13 with 3 valence electrons, all the way down to group 18, which is going to have 8 valence electrons. We saw that, or you saw that on the first little video and the first handout that's in Google Classroom. So this is how you do the valence electrons. Why are we not interested in 3 through 12? They don't behave very well. Group 1 and Group 2, the S block and the P block, are called the representative elements. And just like when you go out to visit a school, an elementary school, and you are in your uniform, you are representing the school because you're well behaved and you're properly dressed, the representative elements do what we expect them to do. So, rule 2, you're going to total up the number of valence electrons. Okay. Rule 3, you are going to draw a single bond between the central atom and each of the other atoms. Okay, so why not just practice with water? Okay, here's our skeletal structure for water. Hydrogen has 1 valence electron. The other hydrogen has a valence electron. Oxygen has 6 valence electrons, and together we have 8 valence electrons. So I've drawn a skeletal structure, I've totaled up the valence electrons. Put them in the pot, they no longer belong to anybody in particular anymore. Draw a single bond between the central atom, the central atom and the outer atom. 1, 2, 1, 2. Now I've got 4 valence electrons. I would complete the octet then for the outer atoms, except hydrogen never has more than 2 electrons by it. So we're going to take these 4 electrons and complete oxygen's octet. Later on, I'm going to do some samples on a tablet, and I'll show you more of this. But draw a single bond between the central atom. If you don't do that, it's not bonded, and the other atoms. Then you complete the octet. Last thing, and I'm not even going to try to explain it now, we'll just do some examples later. If the octet rule is not meant for the central atom, means we don't have 8 electrons around it, you're going to make multiple bonds using lone pair electrons from the surrounding atoms. So what we're going to do is we're going to take some lone pairs that are out here, like this, and we're going to move them inside. So we get X, double bond, X, 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 like that. We've just taken a lone pair and moved it. That's giving me more electrons around the central atom. This is bonded to, say, A. So what you want to write down is this. If the octet rule is not meant for the central atom, you must add multiple bonds using lone pair electrons from the surrounding atoms. Okay, we're going to do some examples on a tablet in a bit. Goodbye.